The universe will die. Every star will burn out. Every black hole will evaporate. Every atom will decay into nothing. That part isn't up for debate. What happens after is, and some of the answers are worse than death. These are 7 real theories from real physicists about what comes next. Some say nothing. Some say everything starts over. One says you might already be a ghost of a dead universe and not know it, and all of them are a real possibility. Let's get into it. Number 1. Nothing. Forever. This is the leading theory, the one most cosmologists actually put their money on, and it's the bleakest one on the list. The universe doesn't explode, doesn't collapse, doesn't get torn apart. It just stops. Here's why. Every single process in the universe, every star burning fuel, every cell dividing in your body, every thought firing across your brain creates a tiny bit more disorder. Physicists call it entropy, and entropy only goes one direction, always up. You can't undo it. You can't cheat it, and given enough time, it wins. Eventually, all the energy in the universe spreads out perfectly evenly. No hot spots, no cold spots, no gradients of any kind, and without a gradient, nothing can happen. No work, no computation, no chemistry, no life. This isn't a fiery death. The name heat death is actually misleading. It's really called the Big Freeze. The final temperature of the universe settles at about 10 to the negative 30 Kelvin. That is so close to absolute zero that nothing is a fair description. And the timeline to get there is incomprehensible. The last star burns out in about 100 trillion years. If protons decay, and we're not even sure they do, all remaining matter dissolves by 10 to the 40th power years. Scientists at Superchemio Konde in Japan have been watching 50,000 tons of ultra-pure water for decades, waiting to catch a single proton dying. Not one. Then come the black holes. The last ones evaporate in a Google years. That's a 1 followed by 100 zeros, and after that, nothing. Forever. Here's a way to feel that. If you compressed all 13.8 billion years of cosmic history into a single calendar year, the entire age of stars, everything that's ever shown, would last another 7,200 calendar years. The black hole era makes that look like a rounding error. And then it's just void. Now picture yourself there. The nearest particle to you is light years away. Photons still exist, but they've been stretched so thin by expansion that they carry zero usable information. You can't see your own hand. Not because it's dark. Because dark implies the absence of light, and this is the absence of absence. Time still passes. But nothing marks it. Nothing changes. Nothing will ever change again. Lord Kelvin proposed this in 1852. A philosopher named Philip Mainlander called it a redemptive destiny, an end of suffering. In 1979, Freeman Dyson tried to fight back. He published a paper arguing that intelligent beings could survive the heat death by thinking slower and slower, hibernating for longer and longer stretches, processing an infinite number of thoughts on a shrinking energy budget, eternal consciousness on fumes. It was beautiful. Then, in 1998, astronomers discovered the expansion of the universe is accelerating, which means there's a finite amount of accessible energy. Even Dyson's slow-motion immortality doesn't work. This is where mainstream physics leaves you. Dead universe, maximum entropy, forever. But most cosmologists isn't all cosmologists, and the dissenters have ideas that are somehow both more hopeful and more terrifying. Number 2. Everything gets torn apart. What if the force that's pushing the universe apart right now doesn't just continue? What if it gets stronger? Strong enough to overwhelm gravity, strong enough to tear galaxies apart, strong enough to shred individual atoms. This is the Big Rip. Proposed in 2003 by Robert Caldwell at Dartmouth and his colleagues. The whole theory hinges on one number. Physicists call it W. It's the equation of state for dark energy, basically a measure of how dark energy behaves over time. If W equals exactly -1, dark energy stays constant and you get heat death. Boring. Slow. Inevitable. But if W drops below -1, even slightly, dark energy becomes something called phantom energy, and phantom energy grows. The more space expands, the stronger it gets. The stronger it gets, the more space expands. It's a feedback loop with no off switch. Current measurements from the Planck satellite put W at about negative 1.028, plus or minus 0.031. The danger line is negative 1. We are within the margin of error. Now here's what happens if phantom energy wins. Caldwell's original paper laid out a countdown using W equals negative 1.5. 200 million years before the end, galaxy clusters fly apart. The gravitational glue holding superclusters together just isn't enough anymore. 60 million years before, the Milky Way shreds. Individual stars scatter. 3 months before, the solar system unbinds. The planets drift away from the sun like leaves off a branch. 30 minutes before, Earth explodes. The expansion overcomes our planet's own gravity, and in the final fractions of a second, atoms come apart. Electrons rip away from nuclei first, then quarks tear free from protons and neutrons, forces that have held matter together since the first seconds after the Big Bang just lose. Then the Hubble parameter hits infinity, and time stops. You'd watch the stars disappear from the sky one by one, like someone switching off lights down a long hallway. In the final minutes, the ground cracks beneath you. And you never experience the actual end because your neurons disintegrate before a signal can travel from one to the next. Your last thought doesn't finish. So what comes after the rip? Honestly, nobody knows. But a 2020 paper proposed something wild. As the cosmological horizon shrinks to nothing, Hawking radiation at that horizon spikes to infinite temperature. The moment everything is destroyed, conditions briefly resemble the Big Bang. Destruction is ignition. The Big Rip is pure violence, but the next theory asks a different question. What if the destruction is just remodeling? Number 3, it all bounces back. What if the universe doesn't die? What if it collapses, hits some kind of floor, and explodes again? A new Big Bang, new stars, new galaxies, new everything. Death as a phase between lives. The math for this has been around for over a century. Alexander Friedman showed it worked in 1922. Einstein briefly considered it. But in 1934, a physicist named Richard Tolman killed the simple version. The problem is entropy. Every cycle would accumulate more disorder than the last. Each bounce produces a bigger, messier universe. You can't go forever. The bouncing has to start somewhere. That was the end of it for decades. But modern physics has found workarounds. Now everything from here is speculative. Serious math, real physicists, but no observational confirmation. Keep that in mind. The most striking version comes from loop quantum cosmology, developed at Penn State in 2006. In this model, quantum gravity prevents the universe from ever collapsing to a true point. There's a maximum density, about 10 to the 94th grams per cubic centimeter, where the fabric of space-time itself pushes back. The universe hits a hard floor and bounces. No singularity, no infinite density, just a limit the universe can't cross. An even wilder variant was proposed by Nikodym Poplawski in 2011. In his version, the spin of particles at extreme densities creates a repulsive force inside collapsing matter. Every black hole triggers a bounce. Every black hole contains a new universe, which means our entire observable cosmos might be sitting inside a black hole in some parent universe right now. A 2022 study showed that even these modern cyclic models still need a starting point. They can't loop infinitely into the past. The bouncing begins somewhere. And just recently, a team led by Henry Tai suggested the cosmological constant might actually be negative, meaning the universe could start contracting within 11 billion years. Big crunch, roughly 8 billion years after that. The bounce is hopeful. The universe gets another shot, maybe infinite shots. But the next theory doesn't wait for a slow collapse. It kills the universe instantly, without warning, and it could happen before you finish this sentence. Number 4. A bubble deletes reality. This might be the scariest idea on the list, not because of what it destroys, because of how. Right now, what you think of as empty space has an energy level. It's set by something called the Higgs field. And that energy level might not be the lowest one available. We might be sitting on a ledge, not the valley floor. A false vacuum instead of a true one. Stable enough to last 13.8 billion years. Maybe not stable enough to last forever. Sidney Coleman described the mechanism in the 1970s. If the Higgs field quantum tunnels to a lower energy state anywhere in the universe, a bubble of true vacuum forms. Inside that bubble, the laws of physics are different. Particle masses change. Forces change. Chemistry as a concept might not exist. And the bubble wall expands outward at the speed of light. The measured mass of the Higgs boson, about 125 giga-electron volts, and the top quark, about 172 giga-electron volts, place our universe right in the metastable zone of the stability diagram. Not safe, not doomed. Somewhere in between. The calculated lifetime of our vacuum is enormous, far longer than the current age of the universe, but it's not infinite. You would never see it coming. The wall moves at light speed. No warning is physically possible. One Planck time you exist, that's 5.39 times 10 to the negative 44 seconds. And the next, the rules that made your atoms possible have been rewritten. It's not destruction, it's deletion. The universe doesn't break, it gets replaced. And this isn't just theory anymore. In 2023, scientists observed false vacuum decay for the first time in a lab using ultra-cold atoms a millionth of a degree above absolute zero. They watched bubbles nucleate in a metastable superfluid. In 2025, a 5,564 qubit quantum computer simulated bubble formation in real time. We're watching the mechanism that could end reality play out on a tabletop. But here's where it gets strange. The energy released by vacuum decay creates new particles, new radiation, like a new Big Bang erupting inside the bubble. Some scenarios predict galaxies and even life could form on the other side, just running on different physics. Others predict instant gravitational collapse. One study showed a universe can spontaneously appear from literally nothing, no space, no time, no matter, through quantum fluctuations in a false vacuum. And black holes make it weirder. A 2015 study found they could seed the decay. A 2017 follow-up said the resulting bubble might collapse into a black hole or pinch off as an entirely new universe. And a 2019 study found that rapidly spinning black holes could actually stabilize the false vacuum, slowing decay below what you'd expect in flat spacetime. Vacuum decay is instant, random, and might already be happening somewhere we can't see. The bubble could be racing toward us right now, and we'd never know until it arrived, which is either the most terrifying thing in physics or the most peaceful, depending on how you look at it. But the next theory says the universe's death isn't random at all, it's built into the geometry, and it might be the most beautiful idea in cosmology. Number 5, death is the next Big Bang. This one comes from Sir Roger Penrose, Nobel Prize 2020. One of the greatest mathematical physicists alive, and his idea sounds like poetry disguised as mathematics. It's called conformal cyclic cosmology, first proposed in 2005. And the core insight is almost absurd in how elegant it is. In the extremely far future, after heat death, after every black hole is evaporated, every particle has decayed, all that's left is photons. Light. And light has no mass. And here's the thing about massless particles. They can't measure distance. They can't experience time. To a photon, crossing the entire observable universe takes 0 seconds. Always has. So when the universe is old enough that only massless particles remain, it forgets how big it is. An infinitely large, infinitely cold, infinitely old universe becomes mathematically indistinguishable from an infinitely small, infinitely hot, infinitely young one. The death of one universe is the birth of the next. Penrose calls each cycle an aeon. The black holes do the cleanup. They swallow all the matter in their galactic neighborhoods, then evaporate over about 10 to the 106th power years, converting everything into radiation. Once all the fermions, the matter particles, are gone and only bosons remain, the conformal boundary between aeons is seamless. Bosons cross it like it's not even there. Now, has anyone found evidence? Penrose thinks so. He and his team identified what they call Hawking points in the cosmic microwave background. Hotspots, they say, are the focused radiation of supermassive black holes from the previous eon punching through into ours. They reported 99.98% confidence from Planck satellite data. The 6 brightest spots showed up at the same locations in 2 completely independent satellite datasets, but independent groups reanalyzed the data and found the signal drops to roughly 1 sigma, basically noise, once you account for the look elsewhere effect. As of March 2025, Penrose published new work showing the temperatures of those spots match the masses of the largest galactic clusters in our own universe, which he considers quantitative support. The debate continues. There are two details here that deserve their own moment. Penrose calls his predicted dark matter particles Erebons, named after Erebus, the Greek god of darkness, and he's discussed how a sufficiently advanced civilization could encode messages in gravitational waves that survive the transition between aeons, letters from the dead universe arriving in the newborn one. Cosmic mail that takes an eternity to deliver and arrives on the first day. CCC says the universe recycles itself with perfect elegance. But what if the universe doesn't recycle? What if it just sits there, dead, for so long that the impossible starts happening? Number 6. Dead universes dream. This one isn't really a theory about what happens next. It's a consequence of heat death that most people never hear about. And once you do, you can't unhear it. If the universe reaches maximum entropy and just stays there forever, then it's basically a box of particles bouncing around randomly for eternity. And here's the problem with eternity. Given infinite time, every possible arrangement of particles will eventually occur, including, by pure chance, a functioning human brain, complete with memories, emotions, a sense of self, memories of a life it never actually lived. Physicists call this a Boltzmann brain, after Ludwig Boltzmann, who sketched the idea with his assistant Ignaz Schütz in 1896. By 2004, physicists had chased this to its logical extreme, and the result is a nightmare. In any universe that lasts forever at maximum entropy, these randomly assembled brains don't just appear. They vastly outnumber every real observer who ever evolved on every planet in the history of the actual universe. The timescale for one to appear is roughly 10 to the 10 to the 50th power years. There is no way to make you feel that number. You'd need more zeros to write it out than there are particles in the observable universe. A Google, the time for the last black hole to evaporate, is nothing next to this. It's a rounding error of a rounding error. And there are bigger numbers. The Poincare recurrence time, the time for the entire observable universe to randomly reassemble into exactly its current state, was calculated by physicist Don Page at 10 to the 10 to the 10 to the 10 to the 2.08 Planck times. He claimed it was the longest finite number ever explicitly calculated by a physicist. Then he beat his own record with 10 to the 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 1.1 years. For a superinflationary universe, language breaks at these scales. Comparison breaks. Math barely holds. And here's the sting. If Boltzmann brains outnumber real observers, then statistically, you're almost certainly one. Right now. Your memories of childhood, of yesterday, of the beginning of this video, all of it fabricated by a random particle fluctuation in a dead universe. You'll dissolve back into thermal noise in a fraction of a second. Most physicists use this as a reductio ad absurdum. If your theory predicts this, your theory is wrong. Sean Carroll has argued that Boltzmann brain avoidance should be a filter for any viable cosmological model. But the problem is nobody agrees on which assumption to throw out. It's an unsolved problem that quietly kills theories in the background of cosmology, and there's a counter-argument. In 2020, a philosopher of physics named John Norton published a paper titled "You Are Not a Boltzmann Brain." His argument: the Poincare recurrence theorem requires a finite phase space in classical physics. Our expanding universe might satisfy neither condition. Brains are quantum mechanical. The weak nuclear force isn't time reversible. The entire argument might rest on foundations that don't exist. But if it doesn't, if the math holds, then after the universe dies, it dreams. Endlessly. Meaninglessly. And some of those dreams think they're real. Boltzmann brains are what happens when nothing happens. For long enough. But the last theory says something is happening. Right now, inside every black hole in the universe. Number 7. The universe is already having children. This is the theory that reframes the entire video. In 1992, physicist Lee Smolin proposed an idea so strange that even other theoretical physicists didn't know what to do with it. He called it cosmological natural selection, and he described it in his 1997 book, The Life of the Cosmos. The idea, when a black hole collapses, it doesn't end in a singularity. It bounces. And on the other side of that bounce, a new universe forms, with physical constants slightly different from the parent universe, not random constants, slightly mutated ones, like offspring. Now apply natural selection. Universes that happen to have constants that produce lots of stars produce lots of black holes. Lots of black holes means lots of baby universes. Over many generations, the multiverse fills up with universes that are very good at making black holes. Our universe, with its stars and galaxies and heavy elements, isn't a coincidence and isn't designed. It's the product of cosmic evolution across billions of generations of universes. And it's testable. There are about 20 free parameters in the standard model of particle physics. Tweak any one of them up or down. If every single tweak produces fewer black holes than our universe currently makes, the theory passes. 40 tests. The odds of passing all of them by accident are about 1 in a trillion. Leonard Susskind at Stanford, one of the architects of string theory, said this idea deserved far more attention than it got. But he also argued that everything we've learned about black holes says information can't transfer from a parent universe to a baby one, which would break the whole mechanism. But here's why this theory changes the video you're watching. In every other theory, we've been asking what happens after the universe dies. Heat death, rip, bounce, decay. All of them are about the end. But in cosmological natural selection, the universe doesn't need to die for new ones to be born. Every black hole is already a new universe. Right now. Our universe has produced billions of them, and inside each of those, billions more, and so on. By the time heat death finally arrives, our cosmic descendants are already out there, trillions of generations deep, living under slightly different physics. The after isn't some far future event. It's already happening, right now, somewhere we can't see. So, 7 theories. 1 says the universe dies and nothing ever happens again. 2 say it gets destroyed so completely that time itself stops. 1 says it bounces back for another round. 1 says a bubble rewrites the rules overnight. 1 says death and birth are the same event viewed from different angles. 1 says the dead universe hallucinates forever. And 1 says the universe has been reproducing since its first black hole formed, and its children are already older than our stars. The real answer to what happens after the universe dies might be the same thing that happened before it was born. We just don't have the physics yet to read what comes next.